In the next modules, we're going to introduce some concepts from machine learning, also known as prediction or classification, and how it's used in genomics. So let's start by defining conditional expectations. Let's use a very simple example, which we've used in a previous module. Suppose you want to predict the son's height from the father's height. So if you're given just this data and you're asked to predict a random person's height, a random person taken from the sons, you would pick the average. Because this is normally distributed data, you would predict with the average, because a 1-inch interval around the average has more individuals in it than any other interval of size 1 inch. Now let's say that I change the problem and I say, assume that you know that the father is 71 inches tall. So now this becomes a prediction problem. We have a predictor, x, the height of the father, and we're asked to predict the son's height. So how do we do this? So one simple idea that is very powerful is to condition the data. So you only look at data where the x is equal to 71, where the fathers are 71, and you look for the value that maximizes the probability. For most data, for example, for normally distributed data, this location where this probability is maximized is at the average. So there we define the conditional mean or the conditional average. So you take all the fathers that are 72 inches and you take the average of those individuals, and that's your prediction. Our prediction is going to be denoted with fx. So for any given x, we want to give a prediction fx. So in this case, we would take all the fathers that are 71 inches right here, and here's a distribution function of just these data here. And you can see that the maximum is somewhere around 70, 71. In the case of data like this that's normally distributed, we already saw in a previous module that the regression line gives us this average, this conditional average, and it has a very simple formula. You start with the average height of a son, and then you add, so you take how many standard deviations a 71-inch tall father is away from the average. You multiply by the standard deviation of the son's height to get it back to the right scale, and then you multiply by the correlation. So this formula here gives us a prediction for any father's height x. And it's actually going to be a very good prediction in this case. In the next module, we're going to explain what happens when you have more than one predictor, like you have in genomics, where you have several genes to base your predictions on.